Hello, ma'am. My name is Gaurav Patil. I'm here to present our project, which is IoT-based predictive maintenance and monitoring system for water purifiers. Our guide is the Dr. Devidas Tosser, and the group member is Gaurav Patil. I am then Karthik Bhagat and Srinath. Here are the contents of the PPT: introduction, problem study, literature survey, drawbacks of existing system, methodology, model information, results and discussion, conclusion, future scope, and references. About our project. The project basically aims to design an intelligent monitoring system for water purifiers using IoT sensors and machine learning algorithms. It will access the real-time health and performance by tracking parameters like flow rate, pressure, and filter efficiency to identify early signs of wear and failure. Predictive maintenance alerts will notify users via connected platforms such as Android application, enabling timely repairs and reducing cost replacements. The solution enhances system reliability, extends purifier lifespan, ensures continuous access to clean water, minimizing maintenance costs, and promotes sustainability. Here are the problems of the existing system. First one is the failure, then monitoring, health risk, and component damage. Basically, the traditional system or existing system has some of the problems such as we cannot monitor remotely, and like modern systems, I'm not able to give alerts that specific sensor is gets a specific filter is gets damaged or not, or it needs an replacement or not. These problems are like we introduced to this system to remove those problems. Here are some of the literature survey that we have referred while during our project execution. Some of the existing system drawbacks such as potential connectivities, then primary disadvantages of the sensor technology, which is high initial cost for installation the sensors. Basically, the industrial sensors needs like high quality of sensors. As a result, their cost is gets higher as compared, which is not affordable for the middle class family. To only include those that are easy to measure, here are some of the basic water parameters that we have used, such as pH sensor, TDS sensor, then pressure, then the turbidity sensor. Then there is a limited research scope in this field. The methodology here is the methodology of our project. First of all, unfiltered water goes from the pre-filter, which is basically used to remove the contaminants more than 5 microns. For measuring the water quality after water passes from the pre-filter, we have used the turbidity sensor and pressure sensor. Then after that, the water goes into the sediment filter. Sediment filter basically removes the contaminant less than 5 microns and more than 1 microns. After that, we have used the turbidity sensors to measure the turbidity of the water. Then there is a carbon filter which is basically used to remove the chlorine quantity from the water. To like check the water quality, we have used the TDS and pH sensor. Then water goes into the RO filter, which is basically used to like remove the contaminants less than 1 micron. We have then to measure the quality of the water after passes from the RO filter. We have used the flow, then TDS and pH sensor. Then after water passes from the RO filter, it goes into the alkaline filter, which is basically used to add the minerals whichever that required minerals removed into the RO filter. Those are added into the alkaline filter. Check the water quality, we have used the TDS and pH sensor. By using these sensors, we can analyze whether the purifier or specific cartridge is working efficiently or not. These data are sent to the database through the ESP32 microcontroller. We have used the Firebase database for the application connectivity as well as to store the data into the cloud. Here is the algorithm that we have used, executes. Basically, it is the type of the gradient boosting and which is a unstable learning technique. The key feature of the this algorithm is that it is fast, accurate, scalable boosting algorithm. Why we have used it? Because our data is structured format and it provides features, importance, and regularization. Like in our project, we have used the examples to like check the water quality levels as well as the cartridge working efficiently or not. So basically, our project is divided into 5 modules. First one is like sensor integration model, in which we have integrated the multiple sensors into the purifier, such as turbidity sensor, pressure sensor, TDS, and then pH. To like control those sensors, we have used the ESP32 microcontroller to manage these sensors inputs and send it to the cloud. Then second is data processing. Basically, the data is comes from the like sensor, so it is a raw in a raw format. So pre-processing the raw sensor data and getting the meaningful physical units, which is our second module, to like removing the raw data and like getting removing the noisy data and getting the like meaningful information from the raw data. Then basically what are the data that we have collected, it is like stored into the JSON so that we can send it to the cloud. The third module, which is data storage. Till now, we have used the Firebase to store a real-time database to store the sensors data. Basically, we are storing this data in the time series format, okay, such as alkaline filter. Then within that pH, and within there is a like reading sections. Within that we have all like sensor units for the specific pH unit. Then fourth module is applying the XGBoost model. After collecting all the data, we have used the XGBoost classification model to check whether the candles are good or working efficiently or not. Then fifth module is the module, our application, which is Android application, which is built by using the Flutter to send the notification, such as if there is a need to maintain like replacement of the specific cartridge or needs to be maintained. These things we can, these alerts that we have sent to the user on their mobile device, which is connected to a purifier. Yes, here are some results. Like first one is the sensor integration, that here is the controller of the pH sensor and the turbidity sensors and pH sensors that we have installed. These are some of the snapshot of that. Then here are the sensor readings which is collected from the database, that how the data is stored inside the database. In pre-filter, here are some of the snapshot which I show you again. These are some of the applications or snapshot where the pre-filter, okay, shows the health of the pre-filter, then sediment filter, their their health as well. And here we have the ranges. We have the ranges of that as well. Like if the turbidity sensor values gets more than 100 and less than 0, then there is a fault inside the turbidity sensor. It also goes for the pressure sensor. If the values goes beyond 200 and less than 10, then there is a fault inside the pressure sensor. Here is the alkaline cartridge, which has then issue because the TDS sensor is giving the value is less than 30. So it is showing the alert in a red format, like red color. Here is the user interface page, that where user can edit their full name, like like email ID. Then it can show like see their filter details as well. The conclusion of our project is to like lays a solid foundation for an intelligent water filter monitoring system by interrupting real-time sensor data, cloud technologies, mobile application development, and machine learning. It bridges the gap between traditional water filter usage and modern smart home automation. With continued development and scaling, the system has the potential to significantly improve public health, promote sustainability practice, and offer a convenient solution to ensure safety and quality of a drinking water. Here are some of the spiritual scope, that is integration of advanced health related water quality sensors, such as detecting the biophysical contaminants, heavy metals such as lead, arsenic, mercury. Then integration with LSTM algorithm for future prediction of the component failure. Then smart filtration health monitoring, such as UV, sterilizer performance, activated carbon filter saturation. There are some of the applications such as residential water purifiers, then commercial industrial plants we can implement there as well. Within hospitals we can install these systems so that we can remotely handle those purifier whether it is working efficiently or not. Then we can also implement into the rural and remote areas and research and environmental monitoring. So here are some of the references of our project that we have used while developing an application. Thank you so much.